Hello dear students, in this video we will learn the sign convention used to solve the numerical problems on the basis of convex mirror and a concave mirror. So let's start a topic. So first we take a concave mirror. So there is a concave mirror. This concave mirror is denoted by dash. P is a pole and AB is our object. So AB is our object, so we consider the two light rays. So these two light rays are coming from the object. So according to rule, a first ray coming parallel to the principal axis, and after the reflection it will pass through the principal focus, and the second ray is coming from the principal focus. So according to our rule, after the reflection it will go parallel to the principal axis. So both these rays are cutting at a point A dash. So A dash B dash is our image. So as you can see there, this image is inverted. Now let's take the parameters. Here PQ is our principal axis. Okay, so a distance between P, pole to the focus, is called focal length. Distance between P and F is called focal length. Now the distance between pole and the object, a distance between pole to object, is denoted by U. Okay, so what is a U? U is a distance between a pole and a object. Now the distance between pole and the image is denoted by V. Okay, the distance between pole and the image is denoted by V. Now let's see how we give a sign to these parameters like focal length, U and V. So we take this is a direction of a ray of light. So we always consider, if it is not given in a problem, we always consider that a ray of light is coming from left side to right side. Now any ray which is coming, which is going, or any distance which is going in the direction of a light ray के direction में अगर हम कोई भी value ले रहे हैं, any value we will take in a direction of a light ray, we will take it as a positive. Okay, all distances taking from pole. Next important thing is that any distance we will take these distance from the pole. Okay, and again I am repeating that direction of ray of light taken as positive. इसका मतलब ये है, it means that any distance which is in a direction of a ray of light, we take it as a positive, and opposite to the a distance which is opposite to the direction of a ray of light, we take it as a negative. Okay, so let's give the sign to these parameters. As you see, the focal length is a distance between the pole and the principal focus. So we measure a distance from pole. So when we go from pole to focus, we go opposite to the direction of a light ray. So we give a focal length a negative sign. Okay, now see the distance of an object. Now when you measure a distance of an object, you go from pole to this distance up to a object. So this distance P to a object is U, and we give it as a negative sign. Why we give it as a negative sign? Because we measure a distance from pole to that object. Now next is the distance of an image. Again we take a distance of an image from a pole. So when we take a distance from a pole, we again go against the direction of a ray of a light. So again we take it as a negative. So in case of a concave mirror, in this particular case, the focal length is negative, the radius of curvature is negative, because when you measure a radius of curvature, again you go from pole towards the left hand side, and your ray is coming from left hand side to a right hand side. So radius of curvature will also come a negative. Now distance of object is negative, distance of image is negative. Now size of object we measure on a y-axis. So because you are going upward on a y-axis, so upward we take it as a positive. So we take it as a plus h. Okay, so size of our object is plus h. Similarly, you can see that image is going into a negative direction, negative y direction. So we take it as a negative h dash. Okay, so in case of a concave mirror, again I am repeating, focal length is negative, radius of curvature is negative, distance of object is negative, distance of image is negative, size of object is plus h, and size of image is minus